Okay, so we want to find the roots of this equation. We want to find what values of x make this thing equal 0. And the first thing we always try to do is try to factor this thing. But we have 5 terms, and we have no general strategy for 5 terms. But we have this thing, our rational root theorem, and our rational root theorem is going to help us find kind of a starting point to start to whittle this thing down. So our rational root theorem says that if this thing has rational roots, it'll be in the form p over q, where p is factors of this constant term, and q is factors of my leading coefficient. So factors of the constant term are 1, 2, 3, 6, 9, and 18, and factors of the leading coefficient are 1 and 3. My possible rational roots then are any combination of these. If I choose a 1 as my denominator, I'll have 1, 2, 3, 6, 9, and 18. If I choose a 3 as my denominator, I'll have 1/3, 2/3, 3/3 is 1, I already have that. 6/3 is 2, I already have that. 9/3 is 3, got it. 18/3 is 6, got them all. And I can have plus or minus of any of these. So I've whittled down the possibility of thousands of infinite number of rational roots to these. So I'll start testing them into here to see if they work and make this thing equal 0. And a shortcut for testing them is to do synthetic division. So I check the setup 4, 3, 2, 1, none. For the powers, I don't need any placeholders. So 3, 5, 25, 45, negative 18 are my coefficients. And I'm going to start just by plugging in, normally I plug in 1, then the negative 1, 2, then the negative 2, and just go on down the line. Here, it looks like I started with a negative 1 because it just didn't, so many of the numbers were positive. I thought, well, maybe I need a negative. So I plugged in. So you always start by dropping down that first number, so that's a 3. Then you multiply, negative 3, add 2. Multiply, negative 2, add 23. Multiply, negative 23, add 22. Multiply, negative 22, add negative 30. Bummer, not 0, sadness. We try again. So we have our coefficients. And then I'm going to try plugging in a negative 2 this time. Bring down that first term first. And I have multiply, negative 6, add negative 1. Multiply 2, add 27. Multiply negative 54, add negative 9. Multiply 18, add 0. Ta-da! Got one. So if you plug negative 2 into that, it works. And not only did we find one, we whittled this down to 3x squared minus x plus 27, 3x cubed minus x squared plus 27x minus 9. Notice it always starts, if this was a 4th degree, then this will be a 3rd degree. You just divided out one of the x's, so whittle the power down by 1. And if I want to know where this equals 0, it's like a fresh new problem. I have 4 terms. I'm going to try to factor the thing. 4 terms factor by grouping. If I take out an x squared, I get 3x minus 1. If I take out a 9 from here, I get 3x minus 1. And hey, 3x minus 1, 3x minus 1, those match. Pull them out of both of those. I get x squared plus 9 times 3x minus 1 equaling 0. Perfect. So if this times this equals 0, then either x squared plus 9 equals 0, or 3x minus 1 equals 0. So here x squared equals negative 9, so x will be the square root of negative 9, so plus or minus 3i. And if you solve this one, you get x is 1/3. So my final roots are going to be the negative 2 that I found over here, the 3i and the minus 3i, and the 1/3. Notice I have 4 lovely roots for my 4th degree polynomial, and we are done.